Let's once again show our reaction. We know it so well. Our acid reacting with water, forming a conjugate base, A- and H3O+. Now, I said we're going to be comparing things a lot. And so I'm going to write up, wow, a second acid-base reaction. And this is different from the first, so we're going to call it A'. It's a different acid, but it undergoes the same reaction. It can react with water, form its own conjugate base, which is going to be A' plus, H3O+. Great, so here are two reactions. And a question that we might have is, which acid is stronger? Now, to look at these two acid-base reactions, we are going to look at them through the two conjugate bases. And you might say, why don't we simply look at the strengths of the acids? And that will tell us which one's a stronger acid. I mean, that, after all, is our question. Which one's a stronger acid? Well, as it turns out, the acids are neutral. And this whole discussion is pointed towards charge. And it's very hard as organic chemists to look at a neutral molecule and say whether a neutral molecule is stable or not. It is much easier to focus on the negative charge, or a charge of some sort. In this case, it is a negative charge on the conjugate base. By evaluating how happy or sad, how stable or unstable this negative charge is, then we will be able to say if this is stable or unstable. Then it'll tell us about the acids. Are the acids stable or unstable? And this works because in acid-base chemistry, if you look at the conjugate base, something that forms a strong conjugate base, well, strong bases arise from weak acids. Or if you look at this anion, one of these two anions, and you say, ooh, that's very stable. So a strong base would be an unstable anion. If the anion looks stable and it's a weak base, so weak base meaning it's a stable anion. You know, if it's a stable anion, it doesn't have a lot of reactivity. It doesn't care if it picks up the proton. Things that don't care if they pick up a proton are weak bases. Well, if the conjugate base is a weak base, that tells us that, ooh, the original acid must be a strong acid. So it's by looking at the charge, whether the charge is stable or not, unstable or stable, that's going to tell us how reactive the conjugate base is, and the reactivity of the conjugate base is a window into the reactivity of the acid. So this is kind of the logic we're going to follow. The questions will be, is the charge stable? If the charge is stable, then we'll say, oh, this thing has high or low reactivity. And if it has high or low reactivity, reactivity how? Well, we're talking about bases. It's a conjugate base. High or low reactivity is a base. Is it a strong or weak base? And then we flip it over and say, oh, it's therefore a weak or strong acid. So this is the logic we're going to follow as we progress through these discussions of acid and base chemistry.